Right now, if you step outside on a clear night in the southern hemisphere and look up, you can see it. A tiny warm dot of light, barely distinguishable from the thousands around it. That's Alpha Centauri, our closest stellar neighbor, just 4.37 light years away. It's been there your entire life, your parents' lives. Every human life, every civilization, every creature that ever looked up at the stars, that light was there, constant, comforting, familiar. Now, what if it wasn't? What if, instead of a gentle companion star, we had that? The most massive black hole ever discovered, TON 618. 66 billion times the mass of our sun, sitting just 4 light years away. Today, we find out what happens next. Welcome back. If you're new here, buckle up, because today we're doing something genuinely terrifying. We're replacing our nearest stellar neighbor with the single most extreme object in the known universe. And we're going to follow this thought experiment all the way through. The physics, the light, the gravity, the tides, the end of life on Earth. And ultimately, the end of the solar system itself. Let's start with the basics. TON 618 is not just a black hole. It is an ultramassive black hole, a classification reserved for the most extreme objects in the universe. Located about 10.4 billion light-years from Earth in the constellation Canes Venatici, it was discovered in 1957 and confirmed as one of the most luminous quasars ever observed. Let's put its size in perspective, because numbers alone don't do this justice. Our Sun, roughly 1.4 million kilometers in diameter. Earth, about 12,700 kilometers. TON 618's event horizon, the point of no return, has a radius of approximately 199 billion kilometers. That is 1,300 times the distance from Earth to the Sun. You could fit our entire solar system inside TON 618's event horizon with room to spare. Its mass? 66 billion solar masses. The Milky Way central black hole, Sagittarius A star, is about 4 million solar masses. TON 618 outweighs it by a factor of 16,000. And in its active quasar phase, the phase we're placing it in for this thought experiment, it radiates with a luminosity 140 trillion times that of our Sun. 140 trillion suns, all blazing from a single point. That is what we are placing 4 light years from Earth.
Let's set the stage. It is a perfectly ordinary day. You're going about your life, the sun is setting in the west, the sky is darkening. And then, something new appears where Alpha Centauri used to be. But here's the thing. Due to the speed of light, what you're seeing happened 4 years ago. The replacement occurred 4 years in the past. What you're witnessing in this moment is light that has traveled 4 light years to reach your eyes. And that light is not like any light you have ever seen. Alpha Centauri, at its current distance, has an apparent magnitude of about negative 0.27, meaning it's the 3rd brightest star in the night sky, behind Sirius and Canopus. Now, let's calculate what TON 618 would look like at 4 light years. TON 618's luminosity is roughly 4 times 10 to the 40th watts. Our sun outputs about 3.8 times 10 to the 26th watts. That makes TON 618 approximately 10 to the 14th times, 100 trillion times more luminous. The apparent magnitude of our own sun as seen from Earth is about negative 26.7. If we scale TON 618 to 4 light years away, accounting for its insane luminosity, the result is an apparent magnitude of approximately negative 38 to negative 40. For reference, the full moon sits at negative 12.7, the sun at negative 26.7, a nuclear detonation seen from nearby around negative 28, TON 618 at 4 light years, negative 38 to negative 40. TON 618 would be hundreds of thousands of times brighter than our own sun as seen from Earth. There would be no more night. Ever. The sky, even the hemisphere facing away from TON 618, would be lit up like a bright, overcast day all the time. The concept of darkness would effectively cease to exist. The sky would glow constantly in all directions because the light would scatter through the atmosphere so intensely that the entire sky becomes luminous. But that's just the light. The radiation is a different story.
TON 618, as an active quasar, doesn't just emit visible light, it pumps out radiation across the entire electromagnetic spectrum. X-rays, gamma rays, ultraviolet radiation in quantities that would be almost incomprehensible. Our sun already produces enough UV radiation that without the ozone layer, life on Earth would quickly perish.
We have the Van Allen belts, the magnetosphere, and the ozone layer all working together to protect us. TON 618 would overwhelm every single one of those shields. The UV flux alone, ultraviolet radiation at 4 light years, would be so intense that the ozone layer would begin to degrade within weeks of exposure. Without the ozone layer, UVB radiation reaches the surface and begins destroying DNA in living cells. Phytoplankton, the microscopic organisms that produce about 50% of Earth's oxygen and form the base of the marine food chain, would be among the first casualties. They live at the ocean's surface. They need sunlight. But under TON 618's radiation, the very sunlight reaching them would be laced with lethal UV. The cascade would be brutal. Phytoplankton collapse, oxygen production drops, marine food chain collapses. Plant life on land begins to die from UV damage and soil degradation. Animals that depend on plants and insects begin to starve. Atmospheric oxygen levels begin, slowly at first, to fall. But there is something even worse. X-ray and gamma-ray radiation from a quasar of TON 618's magnitude at 4 light-years would be severe enough to ionize the upper atmosphere, stripping electrons from atmospheric molecules and further destroying the ozone layer at an accelerating pace. Within months, the surface of Earth would be experiencing radiation doses lethal to most complex life. Underground, deep ocean, these are the only sanctuaries now. Light means heat, and 140 trillion suns means an almost unimaginable amount of heat. We need to calculate the energy flux, how much power per square meter reaches Earth. TON 618's luminosity, approximately 4 times 10 to the 40th watts. Distance, 4 light years, is approximately 3.78 times 10 to the 16th meters. Energy flux equals luminosity divided by 4 pi times distance squared, equals 4 times 10 to the 40th divided by 4 pi times 3.78 times 10 to the 16th squared, approximately 2.2 times 10 to the 6th watts per square meter. Earth currently receives about 1,361 watts per square meter from the sun. TON 618 at 4 light years would deliver over 2 million watts per square meter. That is more than 1,600 times the energy input Earth currently receives from our sun. The equilibrium temperature of Earth, the temperature it would stabilize at, scales with the 4th root of the energy input. 1,600 times the energy means surface temperature equals 1,600 to the 1/4 times 255 Kelvin equals 6.3 times 255 equals 1,600 Kelvin. 1,600 Kelvin. That is 1,327 degrees Celsius. Hot enough to melt aluminum. Hot enough to make silicon glow. Hot enough that the oceans don't just boil, they explode into steam. The steam dissociates into hydrogen and oxygen, and those gases escape into space.
Now let's talk about gravity, because TON 618 has a lot of it. 66 billion solar masses. At 4 light years, approximately 3.78 times 10 to the 18th meters. Let's calculate the gravitational force TON 618 would exert on our sun. F equals G times M1 times M2 divided by R squared. Using M TON 618 equals 66 billion times 2 times 10 to the 30 kilograms equals 1.32 times 10 to the 41 kilograms. M sun equals 2 times 10 to the 30 kilograms. R equals 3.78 times 10 to the 18th meters. F approximately 3.1 times 10 to the 27th newtons. That is an enormous gravitational pull. The sun would immediately begin accelerating toward TON 618 and drag the entire solar system with it. But here's where it gets subtle before it gets catastrophic. At 4 light years, the gravitational field is relatively uniform across the solar system, which spans just about 0.001 light years. So the immediate effect isn't that planets are ripped apart, it's that the entire solar system begins moving, accelerating toward TON 618. This acceleration would be approximately 0.006 meters per second squared. Small, but relentless. Over 100 years, the solar system would have traveled trillions of kilometers closer. Over 1,000 years, the acceleration compounds. The solar system enters a death spiral toward the singularity. But long before that, the quasar jets arrive. TON 618, in its active quasar phase, produces relativistic jets. These are columns of superheated plasma, magnetic fields, and high-energy particles launched from the poles of the accretion disk at nearly the speed of light. These jets can extend for hundreds of thousands of light years. Now, whether one of TON 618's jets is pointed toward Earth depends on orientation.
In our thought experiment, let's explore both scenarios. Scenario A, jets not aimed at Earth. Even without the jets pointed at us, the quasar's radiation alone has already done catastrophic damage, as we've covered. The jets are just additional devastation lurking in the scenario. Scenario B, one jet aimed at Earth. If one of TON 618's relativistic jets were aimed at Earth, even from 4 light years away, we would be hit by a concentrated beam of gamma radiation, X-rays, and relativistic particles that would not merely strip the atmosphere, it would ablate the planet. The energy in a quasar jet is so extreme that at 4 light years, a direct hit would likely erode Earth's atmosphere and outer crust over millions of years, possibly centuries, depending on jet power fluctuations. There would be no meaningful survival on the surface under this scenario.
Let's put together a rough survival timeline for Earth under TON 618 at 4 light years. Year 0, the light arrives. TON 618 appears in Earth's sky. It is blinding. The night side of Earth lights up. People across the world stare in disbelief at a second, catastrophically bright object in the sky. Weeks 1 to 4, the burn begins. Radiation doses begin climbing globally. UV index goes off all known scales. Ozone layer degradation begins. Humans, animals, and surface-level marine organisms begin experiencing radiation sickness. Governments declare global emergency. Every nation on Earth scrambles to build underground shelters. Months 2 to 6, ecosystem collapse begins. Phytoplankton populations plummet. Crop failures begin across sun-exposed agricultural regions. Forests begin dying from UV damage. The first mass extinctions of surface-dwelling species begin. Ocean surface temperatures climb rapidly, not from TON 618's heat directly, but from the intensified electromagnetic environment. Year 1, oceans begin to boil. Surface ocean temperatures in equatorial regions approach boiling. Massive cloud formations of steam blanket the tropics, but provide no meaningful protection from radiation. The hydrological cycle goes catastrophically wrong. Years 2 to 5, surface becomes uninhabitable. Atmospheric temperatures soar. Surface rock temperatures climb toward hundreds of degrees. Any liquid water on the surface evaporates. CO2 trapped in rocks begins to bake out, adding to a runaway greenhouse effect, stacked on top of the direct heating. Surface life is functionally extinct. Years 5 to 50, deep ocean survives, briefly. The deep ocean, insulated by miles of water, remains relatively cooler. Extremophile organisms, deep-sea creatures, and potentially human survivors in hardened deep-sea habitats might persist here for decades. But heat slowly conducts downward. The oceans themselves will fully boil away within this window. Years 50 to 500, a bare rock. Earth is now a bare, irradiated, airless rock. Its oceans are gone, scattered as hydrogen and oxygen into space. Its atmosphere is long stripped. Its surface is melted and resolidified rock, glowing faintly in the unceasing blaze.